Those tiny solar system posters, the ones with planets in a friendly row, have to cheat to exist. To fit 8 worlds into a single page, they squeeze the distances down to almost nothing and blow the planets up far bigger than they should be, until the whole thing looks close and crowded. Stretch the real solar system back out to the honest scale and the picture flips completely. The worlds shrink to specks, and what is left over is a staggering amount of empty space, and that emptiness is the part that should unsettle you. Shrink the Earth down to a single grain of sand. On that scale, the next grain worth mentioning is not nearby. It's a long walk across an empty room, and the big ones are out the door and down the block. In between, there is essentially nothing at all. Space is not the busy star field from the movies. It's mostly cold, silent vacuum, where the nearest neighbor is almost always too far away to matter. That void is the real shape of home, and we're going to cross it slowly, from the inside, until the true size sinks in. Start with the thing that runs the whole show. Almost everything in the solar system, about 99.8% of all the material in it, is packed into one object, the Sun. All the planets, the moons, the asteroids, and the comets put together make up the leftover scraps, barely a fifth of 1%. One astronomy textbook sums the whole system up as the Sun plus some debris, and every map you have studied, every world you have ever wondered about sits inside that thin sliver of debris. To feel that, hold a simple model in your head. Stand the Sun up as an ordinary door, the kind you could walk through. On that same scale, the Earth is not a beach ball or an orange beside it. The Earth is a penny, one small copper coin. The shock is not the coin, it's the hallway. To keep the scale honest, that penny has to sit about 750 feet from the door, more than 2 football fields away, with nothing in between. No air, no dust worth naming, just a long fall of black. And remember, Earth is the close one. The next coin's out, the outer worlds are not down the hall. They are across the whole town. Everything our species has ever done, all its wars and love stories and faces turned up at the night sky, happen on that one copper penny, 2 football fields down an empty corridor from a door made of fire. That is the warm, crowded heart of the solar system. It only gets emptier from here. The model hides one last gut punch. On that same scale, the moon, the only other ground a human has ever stood on, is a fleck sitting about 2 feet from the penny. Out of the roughly 750 feet between the penny and the door, every human who has ever left this planet has covered the first 2 feet and then turned back. Move outward and the worlds swell, but the gaps between them swell faster. Jupiter is a real giant. You could pour more than 1,300 Earths into it and still have room left in the jar. And yet the planet is the easy part to picture. The real shock is the moat around it. The gap between Mars and Jupiter is so wide that you could take every other planet in the solar system, line them up edge to edge, and drop the entire row into that one space with distance left over. A bridge built out of worlds would still come up short. And most of that gap, the asteroid belt, is so spread out that spacecraft fly straight through it without ever needing to dodge anything, whatever the movies show you. Push on to Saturn and the mood turns lonely. When the Cassini spacecraft turned around out there and found the Earth, our entire planet showed up as a single dim speck tucked inside the rings. Simple to miss, lost in the glare of a sun already about 900 million miles behind it. From that distance, everything you have ever known is one fleck of dust hanging in a stray beam of light. Out there, the sun itself has shrunk to a brilliant point. No longer a disk you could shade your eyes against, just the brightest star in a very dark sky. And Saturn is not even the end of the planets. Past it sits Uranus and Neptune, each one billions of miles farther still, in cold so deep the sun gives them barely more warmth than the distant campfire. By the time you reach Neptune, you are about 2.8 billion miles from home, and you've only just finished with the worlds we bothered to name. It would be reasonable to think we are near the edge by now. We're not remotely close. The planets, the giant moats, Saturn's lonely view, all of it sits inside the bright, warm, sunlit core of the system. What comes next is the part that breaks your sense of scale. and how much of it there is. Stay with this because the numbers are about to stop feeling real, and that feeling is exactly what we are after. We treat light as an instant. Flip a switch and the room is lit, no waiting. Out here, light crawls. If the sun went dark this second, you would not know for about 8 minutes. You would keep feeling the warmth and seeing it hang in the sky while the star at the center of everything was already gone. And 8 minutes is only the hop to us, the third rock out. That same beam of sunlight needs about 4 hours to crawl all the way to Neptune, the farthest planet. The quickest thing that exists, the speed limit of the universe, still burns half a working day just getting to the edge of the planets. Now drop to a speed your body understands. Board a passenger jet, aim it at Pluto, hold a steady cruising speed and never land. You wouldn't arrive in a year or a decade or a single lifetime. The flight would run somewhere near 800 years. You could be born on that plane, grow up, grow old, and die, and your distant descendants would still be at the window, watching the same black nothing, nowhere near Pluto. That crawl changes something we never think about: talking. Out among the outer planets, a radio signal moving at the speed of light can take hours to reach a spacecraft and hours again to come back. There is no live conversation with anything out there. Send a question and the reply lands the better part of a day later. It's why steering a probe in the deep solar system is nothing like driving. By the time a picture of a hazard reaches Earth, the spacecraft has already shot far past it. Engineers can't react in the moment. They have to predict where the machine will be hours from now and mail their instructions into the future, trusting the dark has not changed the plan. And the machines themselves aren't slow. The fastest one our species has ever launched, New Horizons, tore away from Earth at around 1 million miles a day and still needed almost 10 years to reach Pluto, roughly 3 billion miles out. Out here, distance is not honestly measured in miles. It's measured in human lifetimes. And the planets are barely the opening act. Everything from the sun out to Pluto fits inside a single bright bubble blown outward by the solar wind called a heliosphere. The wind doesn't stop cleanly. First, it slams into the thin gas between the stars and slows in a shock front about 9 billion miles out, then finally dies at the true boundary, the heliopause, around 11 billion miles from the sun, far beyond the last planet. Only the 2 Voyager probes have ever crossed that boundary. They launched almost half a century ago, have been flying ever since, and only recently slipped past it. Our farthest ambassadors, after a lifetime in the dark, are barely at the rim of the sun's own bubble. Cross that rim and you're still not free of the sun. Wrapped around everything in a shell so vast it makes the planets look like a footnote, sits the Oort cloud, a faint sphere of frozen comets reaching out to perhaps 186 billion miles and beyond. It may hold trillions of icy bodies, yet so spread out and so dark that a ship could drift through the middle of it and never see a single one. The numbers for crossing it stop sounding real. Moving at the speed of Voyagers, reaching just the inner edge of that comet shell would take roughly 300 years, longer than the United States has existed. Pushing all the way through to the far side would take something close to 30,000 years, longer than human civilization itself. Only there, at the outermost fringe, does the sun's grip finally fail and the pull of the next star begin to win. Lay the whole thing out at once and the picture is hard to sit with. A tiny, bright, warm island of rock and light, adrift in a freezing dark so wide that the island barely counts as a rounding error. We don't live in a busy solar system. We live on one lit speck inside an almost unimaginable amount of nothing. And all of that, the planets, the giant motes, the heliosphere, the entire Oort cloud, adds up to just the sun's own backyard. Step past the last comet and the real distances finally begin. Everything humans have ever touched, all of our probes and the footprints and signals, is still rattling around inside that backyard, nowhere near the fence. The closest star to our sun is Proxima Centauri, about 4.2 light-years off. Light, that same beam that already needed 4 hours to reach Neptune, takes more than 4 years to cross from that star to us. Written out in miles, it is a number with 13 digits, somewhere near 25 trillion miles of unbroken black. Send the fastest probe humans have ever built toward it, And the trip would not take years or centuries. It would take tens of thousands of years. The Voyagers, if they were even pointed the right way, would need something like 75,000 years to cross to the next star over. So the whole void we just spent this journey crossing, the planets, the comets, the full reach of the sun, turns out to be a single step on a staircase that runs off into the dark farther than anyone can see. So the next time you stand under a clear night sky, try flipping what you look at. Don't focus on the stars. Look at the black between them. That darkness is not empty backdrop behind the show. It is the show. It is the true size of the place we live, and the bright dots are the rare exceptions scattered through it. We're passengers on a single grain of dust, falling through a void with no edge we can really feel. And maybe that is the reason the grain is worth protecting. We've just ridden straight out from the sun, across all of that emptiness to the ragged edge of its reach. But we've been facing the wrong way the whole time, staring out into the dark. Turn the camera around. From all the way out here, what does our entire solar system actually look like, seen from the outside? That video is on your screen now. Go take a look.